Welcome to Microsoft Build. Today we're going to talk about driving better outcomes through API first development. We've got a lot of really great stuff to show you. I'm Mark Weitzel. I'm a principal architect in Microsoft's developer division. I'm based in North Carolina, and I've had the good fortune while I've been at Microsoft to work on a number of things. I run our API stewardship board, which is a group of architects and principal engineers, SDK architects that work across our Azure service teams and partner with them to build and think about the developer experience of Azure and our API surface area. I've also worked on the developer CLI and a new design language that helps you create OpenAPI specifications called TypeSpec, all of which you'll see here today. I'm joined by Shawn Gaul, who's a senior software engineer in our industry solutions group. Shawn?
I'm Shawn. The group that I work with does a lot of engagements with clients across the globe. Our crews do code with engagements where they work directly with the clients as if they are a part of that organization. My team in particular operates as subject matter experts for distributed application development, and we kind of go in and help those dev crews out when they need greater assistance in that particular area. But we also take some of the feedback and learnings that we get from those client engagements back to the product groups to be able to enhance them. As Mark mentioned, I do also sit on the API stewardship board, trying to bring that voice of the client to them as well. Been with Microsoft coming on 8 years now, but a total of over 20 years of experience in the industry.
So we talked about in the intro how we're thinking about APIs and how leading with a specification first or API first development model really drives your business and leads to better business outcomes. And we see companies across the industry that are investing in this API first models, or we're surfacing their services as a well thought out API surface area. They experience tremendous growth, and this is a trend that we know is only going to continue more and more, and it's critical for Microsoft and our business as we think about Azure and people consuming, our services that we provide. These are oftentimes foundational for things that these companies that you see here are building. So another aspect of this is when we think about APIs, a lot of times it's what do I find as a developer on the web? What's the API surface area of some service that I want to go off and build on or incorporate? And it turns out that there's going to be huge growth, not only of those external APIs, but of internal APIs as well. So all the services that you're building internally, those are going to be exposed and consumed as well by other groups inside your organization. And that's certainly true here at Microsoft. And so as we think about the growth of APIs and we think about APIs, they really do drive all aspects of business. And so thinking about API first, how you take the concept that you have in your head of a service or something that, a capability that you need to provide, and how you get that into the cloud and get that working, right? We need to compress that time, and we need to do it in a way that is repeatable. We need to do it in a way that is resilient, that it doesn't break over time, that it can grow nicely, that it's intuitive to understand. These are all the kinds of things that as API stewards, Shawn and I think about all the time. When we work with service teams, we think about how things are named or how things are structured or how consistent an API is. And so today, what we're going to talk about is and show are really kind of a journey of 3 parts, or in 3 acts, if you will. The first act that we're going to talk about is how you design your API. And I mentioned earlier on that we've got a new language that we're dealing with called TypeSpec. We're going to show how we're starting to use that, how teams can use it, and how you can use it as well, because it's an open source project that you can get from GitHub and start working with. And as we mentioned, that's going to produce OpenAPI. That's our contract. Not only does it feed a large part of our tool chain, but that's really our contract with our customers. And that's also our contract internally that we have. So both client and server have to adhere to that OpenAPI contract. And one of the reasons we've looked at TypeSpec is, if you think about our surface area inside of Azure, it can be quite large. And so TypeSpec will help with that. And I'll show you how that is in a minute. I mentioned earlier in my introduction that I worked on the Azure Developer CLI, or AZD. What we've done in this demo that you'll see is Shawn worked with a customer who took an AZD template and kind of made one of their own and took some of that generated code and dropped it in so they can quickly provision all of the code and infrastructure up on Azure. And Shawn's going to show you an approach that walks through that. And so we can think about that as the first two parts of this story that we're going to go tell. But how do you help people consume your APIs? As Shawn and I have talked with customers and worked with customers, one of the questions that we frequently ask is, do you create client libraries for other teams to consume? Do you create an SDK for your customers? Often that answer is no, they don't. It's hard to build in multiple languages, hard to maintain. It's a lot of energy to produce one of those things and maintain it. The Microsoft Graph team, which Microsoft Graph also has a very large API surface area, has been thinking about how to make consuming of APIs easier. And so they've been working on a project called Kiota, which will generate some client libraries for you. And you can think of it as that plumbing code. And that's the third part of this. So design your API, create an implementation of your API that runs on Azure, consume that API through client libraries in a variety of languages. We'll show Python using the Kiota code. So that's it in 3 acts. So let's talk about Act 1, our spec first design, or our API first design. And as I mentioned just a moment ago, inside of Azure, we have lots and lots of services and lots of services inside what we call service families. So think about Azure Communication Services or Azure Cognitive Services or even Maps, where you have a service family, and then you'll have text analytics or speech analytics, vision, things like that you'll want to use as a developer and incorporate into your applications that you're building. And so those API definitions and those surface areas tend to grow very quickly, and they are often done by multiple teams in multiple geographic locations. So if we think about consistency, cognitive load, and understanding one of these very large documents that evolves over time, that can be challenging. And so we were looking at a way of how do we think and reason about APIs differently? And so we came up with TypeSpec, which is a new language, and I'll show it to you here in just a minute, for designing APIs. And as a language, you compile it down and emit various artifacts, and one of those artifacts is an OpenAPI document. And because it's a language, you get a lot of reuse, right? It's going to look and feel and behave like code. And that really promotes that reuse and that sharing, and you'll get IntelliSense because of that, right? Because it's built in nicely to VS Code, where you get kind of the red squigglies underneath, the code by red squigglies. But one of the things that we have found extremely valuable in TypeSpec is that it really helps us implement our organization guidelines. It helps us implement our REST API guidelines. So if you went out to the web and you did a Bing search on Azure REST API guidelines, you'll find the exact set of things that we tell our service teams to do when they're building their REST code, right? REST API. What methods to use, whether you're using get or puts or patch, whether what return values you need to have. So all of the things that make a REST API consistent, we've put down inside a set of guidelines, and we expect our teams to do that. We have linting rules and Spectral and other tools that help with that. But those are all sort of after the fact. What we're trying to do is think about how do we get further up in the cycle with our engineering teams, our service teams that are building these APIs, and how do we ensure that what they're creating strictly adheres to our guidelines? And TypeSpec allows us to do that because we can actually write in code a library that our teams now use. And so we know if they're using that library, the structure of their operations are going to be the same. The patterns that they implement for things like long-running operations or pagination, they're all going to work nicely. So let's take a look.
Also gives them that opportunity. It also gives them that opportunity within those service families to extend that core set of libraries to create their own standards within there. So that as you go from operation to operation, where there might be deviations or things that are very specific to that service family, they can encapsulate their own libraries as well, right?
Absolutely. So let's take a look. One place that if you wanted to do a little bit of follow along here, one of the things you can do is go to aka.ms/try TypeSpec, and you'll come to what we call the TypeSpec playground. And so this is a very simple way to start looking at TypeSpec and getting an understanding of it. So right now, we'll just take a simple HTTP service and drop down, and you can see that this renders out an OpenAPI YAML file. And so this is our OpenAPI specification on the right-hand side of the screen, and what TypeSpec looks like on the left-hand side of the screen. And so you can already start to feel that code-like experience here. So I have an import statement where I'm importing a library, and this is one of the base libraries that comes with TypeSpec. And I start to define a service inside of a namespace, and I have models that are going to be modeling the things that I do. I have things like an error or a widget here. And then how do I start to expose that over HTTP and REST? And so I have things like a get operation or a put or a post, so standard HTTP verbs. And so you can feel, you can get a sense that this starts to look and feel something that's much more natural to a developer. And so if we look at what gets generated over here, you can see I have a very compact and succinct way of talking about an API that renders, quite a large, even in the simple example, OpenAPI document. And I can drop this down here and take a quick look at, if I wanted to see the OpenAPI visualization, I can do that as well. Okay, but I'm a developer, so I'd like to work in code. So let me slide over Visual Studio Code here, and we'll take a look at TypeSpec. Now, we've done a little bit of the easy bake oven, if you will. So there are some things in here that we'll go ahead and take a little shortcut to. So I'll just go ahead and check out some code here. And so here I've got a main TSP file, and that's the exact same file that we looked at before, except I've started to update it with my models and the things that I look at. So you can imagine, for example, that we are, in this case, building a concert ticket application. And so one of the things that I have is a concert. If I'm selling tickets to a concert, I should be able to understand what a concert looks like. So I've defined, again, that same import of HTTP. I've said I'm using it here. I've got a service, which I'm calling the Reli Cloud service. And I've defined a namespace called Reli Cloud. And here I start to map out what the core resources in REST would be, or the core models that I work with. And you can see I have what we call decorators here. These little @ signs are decorators. And this just means this is documentation. And then I have a type system. So this is an ID of type string, an artist of type string, etc. So you can see I have a very straightforward and simple way of starting to express things that are going to be represented in my API. And interestingly, things like integers and times are one of the areas that many of our teams stumble upon that we see often in a code-first approach. We'll have something that comes in that works well in a type language like C#, but as we think about generating that out into a non-type language like Python or JavaScript, the numbers are represented differently. And so what ends up happening is we get this kind of odd mismatch. And that's not something developers typically think about when, C# developers typically think about.
We also have issues with enumerations, but also it's simple things like naming conventions that apply from one language to the next. When you end up generating from that source code, I mean, you can see the language implementation right there in the OpenAPI spec. You don't even have to guess at it.
Yeah.
So starting here takes the language out of the picture and starts saying, let's really think about what our spec should look like, what our API should have within it. Yeah.
So just like that simple example that we saw before, where we did some gets operations to get the things, I've defined an interface here called a concert interface. And here I have a get, a post, a patch, and a delete. So great. So now we have a basic operation on a basic model, and I've thrown in an error as well. And so this is essentially a little bit of cut and paste from the TypeSpec playground, and then I've added my own model. So I mentioned this.
I'm also seeing a lot of things that I would expect from TypeSpec, like the question mark and identifying optional parameters in there. You also have the expansion, the ellipse there to expand out the property. So it very much feels like a TypeSpec kind of implementation. Yeah.
Yes. Yeah. If you're a JavaScript developer, this is going to feel right at home for you. And for those that are coming from, a typed language, it's not hard to understand, right?
Yeah.
Mentioned that this was a language, so I need to do a TSP install. And so this is actually going to bring down all the required modules that I have here. So as this goes off and installs itself, you can see now that I have node modules here. And one of the things I'd like to do is compile this. And so I'm going to say TSP compile, and I'm just going to put in a dot there, and that will compile it. It says it's compiled successfully. And so I know my output file is here because it's in the TSP output and it's an OpenAPI. So let's go look at that. And there's my OpenAPI. And so I have a very small TypeSpec file, which we call a teaspoon file for TSP. And it's generated out this nice document here. And I can take a look at that also over in the preview. So there it is. I've got concerts, I've got gets and posts and patches. And so this starts to look and feel very quickly like an OpenAPI document that I can share and have other teams start coding against, because again, it's that contract. So I mentioned one of the things that TypeSpec is really, really good at is this notion of refactoring and this ability to kind of let you think about and reason about your API surface area, much like you do code. And we refactor code all the time. So one of the things that we'll do now is show one of the, some of the refactoring that we have here. So I did a quick checkout of step 2 here. So if I just refresh that, you can see. And so what's happened when I've done that checkout? So you can see my main TSP now is much smaller. So I have just the service defined inside of it. And I've imported a routes.tsp. So I've started to factor out from this one big file that I've had. I've started to factor out various parts of it. I've started to factor out the models, which will be in the models TSP. And I've started to factor out the routes, or how those things are exposed. And so this allows us to start teasing apart and separating the concerns inside of our service. So let's take a look at the models TSP here. And you can see it looks very straightforward. I've still got the same namespace, so everything's going to fall in that same kind of containing namespace, if you will. There's my concert, and there's my error. So those were the two models that I had. And here's my routes. And so now we've started to simplify how we think about our API. So we've taken, instead of this one large, big OpenAPI document, I can now say, oh, I've got a service. That service has models. And how do I expose those models? And this is extremely helpful when you're working with teams or developers that really reason about what are the resources you have. And you can focus on, oh, what's a concert look like? What do the names look like? Are developers really going to understand that how to use and incorporate this object, this resource in their code?
Trying to reduce that cognitive load of the engineers who are trying to figure out how to
Yeah.
add and expand to it, right?
Yeah, absolutely. And cognitive load is a big challenge as your surface area grows. So great, I've compiled this, and just to show there's nothing up my sleeve here, the API is effectively the same, right? We've just refactored how we reason about these things, refactored the code. All right, so now let's do a little bit more sophisticated refactoring. And in this next step, what I'm going to do is I'm actually not only going to refactor the code a little bit, I'm going to add some additional models because, you know, Shawn's come to me and said, hey, we don't do concerts now. We also do conferences and symposiums. And so how do I add these things quickly? We've also been working with our API stewardship board that says you need to expose your REST APIs, your endpoints, in a very specific way. And so we're going to show how to do that. And then we're going to show how we can take some commonalities and put them in a common library. So let me go and check out that code. Okay, so here we go. So through the magic of GitHub, we are now up to date. And now you can see that I have 4 TSP files. I have my original main.tsp. And now I have the routes TSP, and we'll jump into that in a moment. Our models TSP, and this new one that we call API library.tsp. So let's look at our models first, okay? And so up here you can see that instead of just a concert now, I have this notion of a base event or a base rally event, right? So there are things that concerts and conferences and symposiums, they all share. And so I've refactored this into a common model. In addition, as Shawn talked about before, we have this spread operator, and this is very similar to, you know, the spread operator that you'll see in JavaScript or TypeScript, and that all of the things that are in this resource metadata object or model are going to be spread at the end of this here. So I've got this notion of resource metadata that's also common. So again, this very code-like experience to thinking about the resources inside of your API. And so concert now becomes very, very simple. It's what's unique to a concert. Same thing with conference. It's what's unique to a conference. And so here we've also created a speaker for the conferences. And here's that common metadata that we talked about here. So I've got resource metadata. It's all optional as indicated by the question mark. And we've got now the strings for created on, created by, etc. And as we talked about before, those things are going to get spread into each of these objects, each of these models when we generate the OpenAPI. And we've also factored out down here a little bit the enumerations for, this is another one for our credit card types. And we've also factored out our error, which we'll see in the library here in just a moment. So let's generate now our OpenAPI document. And let's take a look at that, because this is going to be kind of fun. So here we go. We've started to refactor these pieces here. And you can see, oh, wait a minute. I've got some gets and some puts and some patches. So I've got some new operations. So where did those come from? All right, well, let's go take a look at where those came from. So I'm going to close my OpenAPI YAML down here. And those came from the refactoring of our routes. And so one of the things that we're able to do is reason about our routes and express them a little bit differently. So here, I've got a get conference, which is a list and takes a parameter in here. So wait a minute, this starts to look a lot like code. And so where are those defined? Well, let's go see where that's defined, and that's in our library, right? So let's remember the get conference is list and taking a conference in there. Okay, so here it is. Here's the error model that we talked about before. I've refactored that. And now let's start looking at our routes. So here's that list operation that we had. So I have a list that takes this T. We refer to T as a template. So I have a list that takes a template or a resource. So this is going to get me a list of resources. And notice that I've modeled this operation as a model itself. And so why do we do that? One of the things that Shawn and I often encounter when we work with teams are how to do pagination or how to return collections of things. And so here you can see this doesn't return just a native array. It actually returns an object with an array of the templates or the resources called value. And it has a next link in it. Why do we do that? If you read the Azure REST API guidelines, we recommend that you return a next link and declare your collection as paging, because if you decide to add it later, say in the next version of your service, that's a breaking change. And so you actually have to support two APIs that effectively do the same thing so we don't break customers. And pagination, even if you don't return the value, the next link, you can still declare yourself as pageable. And in similar fashion, when you have an array, you can't add any additional information around that array. Say you needed to add some metadata about how long the query took, or a schema of the things inside the array. Any information about those resources or any expansion of that return value is a breaking change for us. So we always advocate that you return from lists an object, and that object has a value inside of it. And so this is something that you'll see inside of Azure as well. This is one of our patterns that's in our Azure API guidelines.
And essentially encapsulating those patterns that are intended to help our engineers future-proof their services in ways that they most likely sometimes don't think about. So by adhering to this core set of standards that are now in a library that I can reuse over and over and over again, it actually takes more work for them to deviate from these standards than it does to actually implement them, right?
Absolutely. And same thing with this application merge patch. We recommend using patch as a way to update resources. And so sometimes teams will come in with, a patch, but they'll forget to add merge patch plus JSON as the content type. And again, that's a breaking change for us. And so as we start to declare our interfaces here, so we have a set of standard operations. And so here's a list operation that we saw before that takes the template, and it's going to return that value of that collection here that is the model that we've defined above. And same thing here, we can actually model our operation. So I have a model of a merge patch, and here my update operation takes that template, returns that template, and here you can see I spread in the parameters inside that operation here, and I return the template that we've done or the error that we saw below. So again, a very code-like experience for defining exactly how you want your APIs to behave. And so now we can flip over to our routes and see how that starts to get applied. And so now my interface becomes very simple. I have this conference interface that does a list, that does a read, it does a create, and does an update. And now it also becomes very simple to do conferences, which I just showed, or concerts as well. And you're not just limited to the standard operations. You can also add additional routes inside of there. So here's the one that is what we call our action pattern, which is a post. It takes this :suggest model inside of here to indicate it's more of an RPC-like approach than a true REST approach. And we often use these for long-running operations in Azure. And so you can see this is how we structure our APIs. And we could, if we wanted to, get even more simple than that. If we look and scroll down to symposiums here as an example, you can see that we could actually just say, this interface extends the other, and I'll get all of those operations. So that's really a design choice. And again, if we go back and look at our OpenAPI document, you can see that now that simple API document with just a few resources and a few operations has really expanded to over thousands of lines of code that as a developer, you sort of have to understand and manage in your head. And now if we just look at it here, This is in fact a full-fledged, contract that I can give to other service teams to unlock them and get them going. And this is how we can do spec first, think about our interface, define that, and then let our front end and back end service teams go to town. And so to talk about the front end and back end service teams, let me turn it over to Shawn, who will show how we can generate some service code and then some client code here. Shawn.
Yep. So now that Mark and team have created a awesome design for us to work with, let's think about the developers that need to implement this API and build it from there. They've got a lot of things that team needs to think about. They need to think about the infrastructure that the API is going to be hosted on, whether that's Azure Container Apps, whether that's functions, whether that's web APIs, whether that's on-prem systems. What kind of frameworks? Are they using ASP.NET? Are they using the mean stack? All of those kinds of things. Are the libraries that I plan on using approved for within my organizational enterprise standards? How do I configure my pipelines for deployments for CI/CD? Am I meeting my monitoring and logging and security requirements? And what kind of tools do I need on my local machine to actually start building this thing out? So what I'm going to demo is I'm going to demo Azure Dev CLI and show how it can be used in a way to really accelerate that development team's implementation of this API. Right? It's going to end up having the template that provides all those necessary components for them to start off of that. It incorporates the organizational's best practices, and it really enables our developers just to focus on the code. Right? Let's go ahead and exit out of this presentation. We'll switch over. Where I'm at right now is I'm pretty much where Mark just left off at. I have the main teaspoon files, the models, the routes, the Reli Cloud API, all of the same things that Mark was just showing you. I'm going to kick off a couple of different things, and then I'll talk about what's going on, because these things take a bit of time to implement, to run. So first, I'm going to use this AZD template here from our TOSA organization, and we're going to function. What it's doing is it's just going out and pulling out a GitHub repo that has the Azure Dev CLI template in it. There is a file that's in Mark's directory that I'm going to be pulling down an update for, and I'll explain what's going on there in a second. I also need to give it a name. We're going to call it Build 23 for 2023. That environment name is going to be reused within the infrastructure components. And I'm also going to kick off a deployment of this. What this will actually do is it'll create all of our infrastructure resources and push them out into the Azure subscription I've pre-configured in here. Right. The next thing that I'm going to do is I'm going to go into that same directory. Open it up in VS Code. And you can go actually look at inside that Dev CLI. Okay, so this service API has quite a number of different things in there. This API generator we'll talk about in a bit. The dev container itself has our Docker file for running the machine, running the solution locally in a dev environment. The dev container itself, you can see it's pulling and it's using the .NET 7 image. We've got a couple features that we've ensured are there. We've got Docker and Docker. We've got Node. We've got the Azure CLI also being implemented. And you can see we're installing Java as well. That's because the API generation tool that we're using requires Java on the machine. So this dev container gives that for us. It has the instructions. These are all the things that you're going to need to develop in this environment, as well as extensions that should be lit up inside your VS Code implementation. And the last thing you can see, we're actually doing an npm install of this OpenAPI generator tool here, this OpenAPI CLI. So if we go back, we should actually be done with both of these things. Over here, this guy's still running. So let's bounce over to the code window. And you can see all that stuff that was in the Dev CLI is down here, along with that main teaspoon file, the models, all those components that existed there before.
So Shawn, what you showed us in GitHub, that's the actual template that we'll be using. And that template, which is an AZD template, contains that infrastructure definition. I think in this case it's Bicep, but you can use Terraform if you wanted to. And it contains everything we need that's going to host our application that we're going to go build. Is that what I understood there?
Right, and that's where I was going to go next. So if we look at that piece here, you have 4 bits of functionality with App Insights, Container Apps, the Cosmos DB, Key Vault, Log Analytics, Service Bus. Now, for our purposes of the demos, we're not deploying a Cosmos DB or a Service Bus, mainly because it takes quite a bit of time, and we really don't need them in place for this demo to work. But in the scenario that this particular template was inspired from, there was actually a blend where there were shared resources that already existed inside the platform. And then there were components that were specific to this app. So things like the Azure Container Registry, things like the VNet integration components, the VNet piece itself, those already existed inside the platform. And this Dev CLI hooked into them through the parameters that were provided inside of it. So we've simplified it and removed that VNet integration component, because demoing that in this kind of short time frame would be difficult. But
so this
it gives you
that infrastructure might be something like a platform engineering team would go and set up for you.
Exactly.
All that shared infrastructure, and then you wouldn't have to worry about it. You would get it right from the template or through Azure deployment environments or something like that. Correct?
Right. And what you can really envision that separation of that platform engineering team, who's not only providing the platform itself, but also providing templates, Azure Dev CLI templates that work well within that platform. It really harnesses capabilities in the way that platform engineering team really loves to use. But on top of that, I mean, it's essentially going into a GitHub repo. The dev teams that are using these and consuming these can turn around and contribute back to them as well to enhance them and make them better from their own dev experiences too. Right? And I mean, you can also envision scenarios where you might have organizations that use C# and Node and Python, all having different dev CLIs that all work well within that platform as well. In this case, we're using C#, but you have that capability to be able to use multiple languages as well. The other thing that's inside here is the platform engineering team has created a library of shared kind of components that work well within an Azure Container Apps environment. So they have things like health checks already built for us that do liveness pros and readiness pros. They have the configuration of App Insights and logging components all ready built for us. And if we go into the web API itself, you can see that the health check endpoints and the controller is there. You can end up seeing that there's very little models as well. Our program CS has some pre-built components as well inside here. You'll see that we're adding our health check component for based off of what our platform engineering provided. You can also see some stuff that's here, right? We've got this use static files where it's saying, hey, I'm expecting something to live in this spec directory. You can see where we're also configuring our Swagger UI to expect that OpenAPI JSON to exist inside that spec directory. Right? Neither of which exists right now. You can also see we don't have any controllers, and we only have this one model. So we're going to actually fix that real quick, and we're going to actually run this script. It exists within this template, right? Spelled that wrong. Run that. And let's look at what this script is actually doing. It's actually not, it's a fairly simple script, but it's quite powerful. Let's get past the boilerplate stuff that's at the top here, which is just grabbing in the parameters from the command line. When we look at this echo that we just saw here come out, the first thing it's going to end up doing is going to say compile that spec file, and they're going to emit within OpenAPI tree. Now, remember that one file that I ended up overwriting? That one file has some options that I want to make sure that this template is aware of, right? This guy wants that OpenAPI file to be a JSON file, not a YAML file. If you remember all the stuff that Mark showed, it was a YAML file. By default, TypeSpec emits a YAML. We want it JSON. The other thing is we want it to emit to a very specific directory. So that's what's going on with that first line is it's using that TSP config and it's pushing it out to a very specific location. The next thing that's going on is we're using the OpenAPI generator CLI to generate the models and then the controllers and the APIs themselves, right? The last thing that it ends up doing is some house cleaning stuff where it ends up saying, you know what, the generator pushed it out into these directories. I want to push them out to very specific locations, which is actually configured in this Jenny JSON. And then I want to clean up all of the pieces that were emitted during the process. And you can see it running down here still. As we come to a conclusion, we will be able to see the resulting bits come through. Now, when we close this down, we go into the web API. We now have this controllers directory show up. You can see we have concerts, conference API, image, all of those operations, those API components that came from Mark's TSP, main TSP, are now have a controller representation. You can also see all the models that came from that main TSP and the models directory coming through, even that base Rally event. So you can see we brought over all of those things, but what I really liked about the OpenAPI Tools Generator, or the OpenAPI Tools Generator, is that it gives you this power to use Mustache, and you can really control the output. In this particular case, what's being outputted is a partial class for each one of the controllers, right? And each one of the methods within the class is using reflection to say, go get me a method named this from my class definition. You can notice it's the same name that's here, but it has an underscore right in front of it. And there's a lot of different ways you can end up doing this. And because you have those mustache files, you can end up implementing your own approach. Like, for example, you could have a naming convention that says, hey, my service, I will have a service library for my controllers, and I can inject those through my program CS and have that use dependency injection to have those pieces already here. But really creating that separation, what's important is that separation between what's generated and what the application developers are actually going to implement. So let's do a real quick implementation of that concerts API. I'm going to do a concerts. And then we're going to. This is just a really raw piece, but you'll see we're extending that concerts API controller, that partial class. We've got this method that, remember, we wanted the same method name with the underscore. All we're doing right now is we're just generating out 10 different concerts, all with different title names and things like that. So now that we've got this piece here, let's go back to our command line over here. We're going to end up doing an AZD deploy instead. So AZD up is going to do a packaging. It's going to push out your infra directory components, and then it's going to push out your application codes. So it's actually effectively doing both a AZD package and an AZD deploy. We just want the deploy, right? Or AZD provision and AZD deploy. We just want the deploy for now. One of the interesting things that ends up happening here is that the repackaging of it takes a bit of time, but interesting things here is it gives you this URL, and we'll probably hit it right now as we wait for that to deploy. Yeah, it's still deploying. Let's look at the resource groups real quick. You can see this build 23 is what we deployed originally, and we can end up seeing the different resources. We have our applications insight resource. We have a dashboard for the application insights resource. We have that container apps environment, our container registry, the key vault, all those pieces that came from the infra from over here. The names are generated from that environment name that we initially configured. It's using a a resource token that's based off of that particular name. And you can see that the resource group itself is just the dev environment name -RG, right? Let's go back and look. Yep, we have finished. Re-click on that. There we go. So now we have our same stuff that you saw from Mark's implementation has now been deployed. Deployed to this spec OpenJSON piece. We've got our Swagger UI that's been configured through our program CS. We go into concerts. We can say, try it out. We execute it. You can see we got our nice 200 response, and we've got our different titles coming through: concert 1, concert 2, concert 3, right? Well, that's a fairly interesting way to take some of the open source tooling that exists for OpenAPI already, incorporate it with Azure Dev CLI, incorporate it with TypeSpec to end up really accelerating our development team's implementation of consistent approaches for our organization. Right?
And as you mentioned, because we're not code first, we can create that API contract and have folks start working against that API. Again, we've counseled a number of our teams really to think about API first. And the reason to do that is because we get this nice parallel development. We really think about how the resources should look and feel and behave inside of our services.
Right. Yeah. Exactly. So, and along those lines, the next step that we want to worry about is our people that want to consume our APIs, right? So you want to tell us a bit about scaling this out from implementation of the client side?
Sure. So let's talk about Kiota. As I mentioned early on, Kiota is a project that's being driven out of the Microsoft Graph team. It's open source, so you can go to Microsoft in GitHub, the Microsoft organization, and find Kiota. But really, it's a tool for consumers, for API consumers, and making that much easier than it is. I mean, if you think about these large OpenAPI documents and how you need to manage those, you also have to start to understand them. So Kiota is a way to think about consuming APIs a little bit differently, and it includes a tool inside of Visual Studio that will allow you to discover APIs, that will allow you to select very specific parts of an API if you want, and then generate out client libraries in a very opinionated way. And the way I like to express this is that it is a HTTP REST API expressed in code. And so it's going to look a lot like an HTTP call inside of code, but it generates models for you, so you get all the nice serialization on and off the wire. It generates that plumbing for you in a very consistent way. So if you're just consuming a large number of APIs, you'll grok the pattern very quickly. And not only will you start to understand the pattern very quickly, tools that help us with development like Copilot start to understand that quickly. And so you can very rapidly consume APIs. The Kiota team is actively building a community around this, and they're starting to expand. And it's a very exciting project that I would encourage everybody to check out. And Shawn's going to show us some interesting, fun things here now.
So a couple of things I'm going to do is I'm going to show within VS Code, so the extension that allows you to discover the API and the operations within it selects very specific pieces of it. It'll generate that tailored set of code that is specific to what your selections are made. It'll be compartmentalized so it doesn't interact with the rest of your code. And you have that option to create your own service layer as well. Okay, so we're going to have a real quick look of this, and let me switch over to our demo environment. So we're going to end up saying, let's use this client. And from here, you can see this VS Code instance here. All we've got is a very raw environment. It is Python, so it has a virtual environment already pre-configured here. It's not very interesting to watch a virtual environment spin up, so we pre-did that for them. Let's go ahead and create a requirements. Actually, let's skip that and go straight to Kiota. In the Kiota, one of the things that you can end up doing is you can say, let me go look at GitHub just as an example, right? And it gives you all the options that are related to GitHub. we're going to go off of that first one. And it's going to go and look at the spec that has been defined for GitHub, and it's going to say, hey, look, let's see all your operations that are available within GitHub. I mean, you can say, I can look at the orgs, I can look at the feeds, the events, the markdown repos, and using the plus sign or the minus sign, I can select specific things that I want to use. I don't need to consume the entire GitHub components, right? So let's actually switch over, because we're not really building anything for GitHub, but we are building this concerts component here. So let's get the URL for that OpenAPI JSON. Let's go into this demo environment, and we're going to say, you know what, let's look at this guy instead, right? And it's going to look at it, and it's going to say, hey, you got the API definition in there. We've got the concert, we got the conference symposiums, all those operations, even the post actions that Mark had shown us before. You can end up going in here, like I said, you can plus or minus which operations you want. All we care about though is the concert sub, because that's the only thing we've implemented, right? So we select that, we click play, we'll see some questions for us, right? So we want to be able to give the name, the client a name. So we say it's a Rally Cloud client. We are only interested in doing the concert SDK, so let's just use that. And we're going to put it in the directory. And you can see there's quite a number of languages that are already in play here, right? So C# is in a stable state. We got Go, Java, PHP, Python, Ruby, Shell, Swift, TypeScript. You can see they're in preview or experimental state. We are actually going to poke on Python here. So let's use Python. And we got a nice little, hey, we just got generated. Let's go back to our file here. You see the only difference is this Rally Cloud directory that's been added into our piece, right? This Kiota lock file is actually quite interesting. It has a hash of when I pulled this down. So that if I do it over and over and over again, and there's been no changes, then it creates a better performance. But if I start extending where I want the concerts and the conferences and things like that, this lock file keeps track of what's been pulled down into this Rally Cloud implementation here, all encapsulated inside that directory, right? We also have an API for the concerts that have come through, and we have our models that concerts operation exposes and will be necessary in there, all within a Python friendly way. Right? The next thing we're going to do is we're going to create that requirements file for Kiota to work, and for my sample to work, we need to make sure that we have the requirements, right? Now, these particular requirements, you can find them on the documentation for Python and Kiota. This Python being in a preview state, this is the way that you would need to go out to docs to figure out which ones are specific, but we'll go ahead and install those. TXT. Okay. Now we're going to go in and create a new main.py file. But what we've got going on in here is typical things you would see from a Python. We're importing our pieces for async IO. We've got the Kiota specific imports as well. I'm also doing the imports of the Rally Cloud libraries that were generated. Our web app currently has no authentication associated with it, so we just need an anonymous authentication provider. And you can see a request adapter that we're building. We need to replace the URL here. Typically, this would be an environment variable, but for our demo's purposes, we'll just paste it straight in there. And you can see we're going to end up doing a Git. And you can remember Mark had talked about the opinionated nature of using the URL to define the class structure, the client structure. So you can see from that URL that we saw within Kiota, it went API, then it went concerts, and it had the operations of Git. So it flows very well with what you see from your URL patterns into the actual calls within the library itself. So I'm going to put a breakpoint right there. I'm going to run that. we're going to come down here, and you can see that all concerts variable that we just build up in there. We expand that, and you can see the value as we define by our operation. All list operations must contain the components. You see that next link. We got our value piece within it. You can see our 10 concerts are coming back with our genre and title and components filled in, right? And if we end up stepping into this, all it's going to end up doing is printing out, hey, we retrieved 10 concerts from there. But it's a very quick, easy way to interact with API specs in a very consistent manner. And it really lets you discover just what you need instead of implementing the entire SDK or consuming the entire SDK. A couple of the, Mark, do you want to talk to the takeaways?
Sure. So there are there's lots and lots of things that Shawn and I hope you take away from this presentation. Really, we think an API first or spec first approach really helps you drive better outcomes through consistency, adhering to your organizational standards and guidelines. And TypeSpec gives you a way to encapsulate and codify those in code that makes it easy for developers to produce those, contracts that can then be, plugged into a tool chain like you saw here to produce very consistent frameworks and templates that you can easily, consistently drive your infrastructure, et cetera. I think this is really about empowering platform engineering teams and letting devs focus on devs and letting platform engineering teams think about the infrastructure and architecture that really drives and right sizes those resources that you work with on Azure. And of course, this scales, right? This is a way to foster parallel development through really adhering to that contract. So spec first development really drives all of this. And this is how you can get better outcomes. And it's a journey, and Microsoft and Shawn can attest to this. I can attest, we're still on this journey, right? We're still helping teams understand and see the value of it. But when this works well and when teams do this, we see a tremendous amount of value in their service definition and their consistency and how they implement their service. So this is a journey. We're encouraging you to join us on that journey. Check out TypeSpec, which is in GitHub, and Kiota, which is in GitHub. And if you have questions, you can find us on your usual social media places. So thank you very much.
Thank you.